This is DevOps in Agile Way podcast.
Hello everyone, this is the second episode of my podcast, and today I'm really happy because we have Lee with us. Lee is a great person. You know, if you follow serverless stuff and cloud stuff on LinkedIn, YouTube, whatever, you should know Lee already. If not, shame on you. Lee, you are the architect, serverless developer, serverless advocate, right? And you are very active. You do a lot of things on YouTube, on LinkedIn. You talk on different events. How it started for you? Because every journey of people like you, right, who start being on the second side of this mirror, right, starting sharing the knowledge is different. So how it came that you are here today?
Yeah, sure. Well, firstly, thank you for the invite. It's great to be here talking to you today. My name's Lee Gilmore. I work as a global enterprise serverless architect, which is a bit of a mouthful, shortened to GESA to a lot of people. And I currently work for City Electrical Factors in the UK and City Electric Supply in the US. So we have essentially many stores, branches, you could call them, globally in North America, the UK, Australia, where we sell things like sockets and wires and everything electricians would essentially need in their everyday life. Outside of that, I'm obviously an AWS community builder. Been doing that for quite a while now. Write a lot of articles, blogs. Most of my articles I write a code repo with it. And that allows people to understand the article itself and then deep dive into the code and, just allow them to pull it down and kind of debug and play with it. But I've been doing this roughly 25 years. I've been in the industry.
Same here. So 50 years of combined.
Yeah.
We are old.
Started back in the day racking servers, working in government, worked with .NET and Java and many proprietary products. And I think it was back in 2014, I was working for a company and very much based in Node.js. Everything was running on EC2 at the time, and was given the opportunity to take this monolith, which was written over 5 years, and had the remit of, let's re-architect this fully serverless, which was fantastic, and look to internationalize this fully. So it started off, I think it was the end of 2014, where Lambda first came out. I think it was like November or December in 2014. Started using it for really small parts of the application. So, generating files and reports and things like that. And we thought, wow, this is amazing. A couple of years on, and I was given this opportunity to rewrite this monolith that we had millions of customers using it, millions of employees, thousands of companies using it. It was a SaaS product. And to move that fully to the cloud, AWS, serverless, fully internationalized, so you could, have this deployed out to many different regions, which was fantastic. And that was it. Did that. It was very successful after 12 months. And I think I got the bug from there, to be honest.
Forward to it.
That's me.
Yeah, that's great, and really thank you very much for joining me today, because this is really important for me, and I really appreciate that. Right, so you mentioned very interesting thing, that switching or re-architecting, right, from the monolith to serverless. This is quite tricky because with something in between, like microservice, we can say that, okay, we will take this monolith and put into the container. It is not the smartest way to do things, right? We know that, but at least this is possible. With serverless, it's quite risky, I would say, right? So, how did you start this approach? Because when Lambda came out, right, it was generally speaking unknown how to deal with this. So you were in kind of terra incognita, right? So definitely out of comfort zone, because in EC2 it was relatively easy. So what was your approach? How you started this? You mentioned that you did it gradually with small services, etc., etc. But what was the decision process, and how it came to life?
Yeah, that's a good question. So we did start using Lambda for small services that kind of worked alongside the monolith at the time. It was, like I say, Node.js and deployed to EC2. And then over a period of time, we realized that it needed fully architected from the ground up. And the reason for that, it was very much based in the UK, the code base. So if you think of an employee, for example, you might have first name, surname, and national insurance number.
Mm-hmm.
But to deploy this globally to, say, North America, national insurance number doesn't exist. You'd have a social security number, and that would have its own regexes and patterns. And this was full stack. This was from the data model in the database all the way to the front end client. So this was essentially build, net new and do a data migration. There was no way to slowly strangle. Obviously, any book you would read would say, do a strangler pattern and slowly move parts across. We just couldn't do it because this remit of full internationalization through the full stack, we just couldn't have done it. It would have just been too slow. And that's where obviously I'm very interested in enterprise serverless and clean code, and that's where these things kind of came into play. So by that point, as we'd played with Lambda and step functions that came out, and then AppSync. So we went down the route of using AppSync and then looking at the Lambdas and actually writing them in the right way with clean code. So we didn't go full clean code for anyone that knows how clean code and hexagonal architectures work. But we did look at stripping out the business logic into its own kind of layer, and then looking at more of the kind of repository pattern for things like the database and persistence. So persistence ignorance, the actual code itself, the Lambda code, the business logic, it wasn't aware of actually where it was persistent to in the way that we wrote it. It also wasn't aware of where the inputs were coming from. So it wasn't aware that it was AppSync, for example. And as long as it confined to the interfaces and the DDOs, it just worked essentially, and that worked very well. An example of why that worked well: halfway through the project, we were very focused on using DynamoDB in the microservices, and that was fantastic. Brilliant scale, cost effective, ephemeral environments, fully serverless. But as we did that, obviously access patterns were something we really had to think about.
Yeah.
We worked closely with the DynamoDB team, which was fantastic, the service team. But then halfway through the project, we also acquired an HR product that now had to be fully integrated. That meant the access patterns went fully out the window. All of a sudden we need pagination, kind of aggregation, projection, filtering all at the same time on any field. And then Dynamo wasn't obviously a great fit. We could have looked at complexities around event source and CQRS and pushing certain read stores to maybe Elasticsearch at the time, like OpenSearch now. But the complexities were just too big. So that's where that kind of hexagonal architecture worked really well. The fact that we'd split out the core logic from the actual persistence mechanisms. So we were able to move very, very quickly, change that persistence from DynamoDB and most of the microservices to what happened to be DocumentDB, so Mongo based. That worked very well. But also on the kind of other side of that, we also had the remit that desktop applications now had to use REST to connect with. So again, that worked absolutely fine. We had the front end applications using GraphQL. But when we needed the same business logic for desktop applications, we just created new adapters for API Gateway. So that's where not going fully hexagonal architecture with value objects and aggregates and what have you, just splitting things out in the right way. And this is the approach I take from a serverless perspective as well. That actually really helped us on that journey, without it being a catastrophic issue.
So kind of pluggable architecture, right?
Exactly.
This is what we can have with hexagonal approach and this kind of idea. Before we go deeper into technicalities of enterprise serverless, very often we can hear that serverless is fine for small things, right? So this is like a argument we can hear multiple times, especially from those people who don't really understand what serverless is. My question is, because on the enterprise level, things are happening a little bit differently, right? There is definitely different speed of adapting, different approach to adapting those things, right? So from your experience, what will be your advice, like one advice for the team of the enterprise architects, right, who wish to look on this approach, wish to look on serverless and adapt serverless in their environments?
Yeah, that's a very good question. So the one thing I have written over numerous years now is an approach called serverless architecture layers, and this encompasses many things. It confines to things like team topologies. It's it very much based on the work of Eric Evans. It is layered architecture, but from a conceptual point of view, it doesn't mean
Mm,
it's SOA or anything like that. But what it does do is it has particular guardrails around as you're actually starting to build out in an enterprise with serverless, some key things you should think about. And the reason for that is serverless is very quick to get started. And that's what's great about serverless, things like MVP, getting things straight out to actually test those features with customers and iterate on it. That's great.
yeah, that's
But
true.
with that, a lot of people might spin up a salad stack. So S3 for a React app, API gateway, Lambda, and DynamoDB. Very easy to do, but that doesn't mean it's productionized. And a
Mm,
lot of teams don't think about things like DR and scalability and having DLQs, for example, and the reporting or compliance around
yeah.
the storing of data. And so yeah, I think it's very easy to get started. And one thing I have seen, this was I think first coined by ThoughtWorks, which is the Lambda pinball architecture.
Mm,
I have seen that working with a few organizations in the past where if you have many teams in an enterprise that all start very quickly going down that serverless route, if you don't have the governance around it, there's a lot of high cognitive load with the
mm,
teams, a lot of duplication. So you might find that one team starts using EventBridge, and then another team's actually at the same time looking at MSK, and another team's looking at another pattern. And what quickly happens is one team says, okay, I need to listen to events from your domain. And it's okay, right? You now need to learn Kafka.
mm,
Okay, great. That's not really going to work. And it's high cognitive load. So that's another key part of serverless architecture layers, which is having that ASB in there. And it's highly opinionated around EventBridge. And there are patterns around that. The single bus multi-account pattern is typically what I go for. But again, it's that governance at that enterprise level where, what does a good event look like? Does it have kind of data and meta properties on it? Are we using event carried state transfer, so fat events essentially with a lot of data on them? And that makes life a lot easier as you start to grow out in an enterprise, having that governance up front, because
mm,
you know how teams are going to communicate bus to bus. You know what the events look like, and that kind of feeds into the platform engineering aspect, which is another key part of architecture layers, which is developer experience. How do you find the events? For some of the domains that you've got, their APIs, how do you know what a good REST interface looks like? And how do you even find those APIs? So this all kind of fits in at that kind of level. So I think having that governance up front reduces the risk of this lambda pinball architecture. And I think the other key aspect of that is DDD, which
mm,
obviously Clean Code's part of. But looking at bounded contexts and looking at domains having private APIs that are, they're domain services that are only accessible through what I call channels and an experience layer. So an example could be, say, raising an order. I would typically have an order domain service or order management, which is private to the AWS network, and that's only accessible through channels. So if I want to raise an order via an Alexa app or via a web app, mobile. They are very thin back end for front ends that access essentially the same domain logic. So again, having that governance prevents people duplicating the same logic and the same capabilities across many different services.
Mm-hmm.
So again, it's just thinking that kind of governance and patterns at that wider kind of enterprise level.
Yeah, that's great. Thank you for this answer. It was really deep and very important. And I catched this. You mentioned team topologies, right? And from some time I already say that IT become people business with all of this more modernish approaches, microservices, serverless, etc. We split the application more and more. We put more and more communication lines, doesn't matter what it is, but communication lines between those microservices, and we need to ensure that those teams who are in charge of those microservices also communicate, right? That's convey law principle, and it's quite important, and I believe it's not enough of mentioning that, right? Because I saw many failures because of that. Right, so thank you for mentioning that. That is a very important point. And coming back to the serverless enterprise approach, how do you see from, let's say, architect perspective? Do the models we have for modeling the architecture are still valid for serverless? Because in my opinion, we need to switch completely, right? Because what we had as a, for example, component diagram right now with serverless is a little bit different, right? So do you see any need to adapt maybe those approaches, especially in terms of enterprise, because there, the architecture is a little bit bigger than two lambdas and one API,
Yeah,
right?
definitely. And this is where I do use the C4 model quite a bit. So that C4 model allows people to conceptually view other systems and other domains, and especially within that serverless architecture layer's perspective, they can understand, okay,
Mm.
there's the order domain and here's the product domain and the sale domain, what have you. So they can see at that very high level. One of the kind of key aspects for me is everything that happens behind that private API gateway, that versioned API gateway that people can find. Whatever happens behind there really
Mm.
doesn't matter within that domain too much. It's encapsulated. So there's essentially two ways to communicate with a domain service, which is through that API synchronously or asynchronously using events, and that's the only way. But it does allow you at that top level with C4 to look at the full landscape, and that's going to be buy versus build as well. There's going to be potentially off-the-shelf products in there, which again should confine to those same standards of the only way to interact with them is through APIs and events. So
Mm.
there's obviously going back to EventBridge, it's very easy to use API destinations where off the back of an event happening to actually then automatically call out and hit a third party service, and it's no different if that third party service wants to raise an event, they can use an event gateway pattern. So they can hit an API, which then essentially puts that event directly onto EventBridge. So again, architecture layers thinks about this holistically. But going back to the complexities, I do think that is a problem as you start to delve into that lower level within that domain in that C4 model, as you kind of delve down to that AWS architecture diagram. Serverless is very complex, and I think it's very complex to view, and I think that's something we haven't solved yet. Even a medium-sized service that might have storage first patterns and many lambdas. You might have DynamoDB streams or change streams of document DB, and a lambda off the back of that. It is for somebody that hasn't actually built it and somebody coming into a new team and looking at that architecture diagram, it is very complex to understand what's going on.
Yeah, that's true. And there is also another layer of complexity. I don't know if you agree with me, especially if we talk about enterprise. And honestly, it doesn't matter if this is synchronous or asynchronous communication. With asynchronous, it's of course a little bit better. But I think that there is an impact of our beloved cold start, right? Because we have chain of things which are happening in application. It's not like a simple lambda which answering the black cat or white dog. And I believe this proper approach to architecture, which you already mentioned, this hexagonal architecture, clean code, has very significant impact on the behavior and the performance of the application, because I believe that serverless is, I would say, quite sensitive to that, right? Because for with EC2 instance, doesn't matter if this is smart approach or not, you can just make instance bigger. And I heard this many times from the support. I just create bigger instance. With serverless, adding more memory, whatever, is not the solution very often. It helps. Very often it helps, but it's not the solution here. So how will you, let's say, encourage people to look on this aspect, especially of the architecture of serverless and approach to coding itself, with this proper understanding what cold start is? Because well, not many people even understand that there are multiple types of cold start, right?
Yeah, and like you say, I think this is where clean code is a big win, actually taking the time to do it properly. So again, going back to teams first starting out, a lot of the time what they would do is just have a handler that has everything in it. So it'll have the domain logic, and it'll have the persistence, it'll have the the SDK calls and what have you, going out to maybe DynamoDB. I think just thinking up front of splitting that out a little bit, so you've got, like I say, primary adapters would be your inputs. That's the technology aspect. So it could be a Lambda handler, or in our case, if we need to move to containers because of cold start, that could be an Express controller or Next.js or something like that. And I think that's where that upfront thought about evolutionary architecture and being good to your future self and building things in the right way, because it is very, very easy to not do that and throw everything in the kitchen sink into the Lambda. But that will, based on what I said earlier, the problems I've had in the past with swapping out from Dynamo to a different data store, same with API Gateway, these things do happen, and especially in an enterprise.
But also, this is another buzzword which is very popular still. It's still buzzword. It's agile, right? And we can apply agile to architecture as well, right? Architect should do what is needed with some idea in mind how it will behave, how it will be upgraded in the future. But still, you don't need to implement everything on the beginning, on the day zero, right? And this is also the power of serverless, because this is easily scalable, not only in terms of performance, but also in terms of features.
Yeah, and this is where I encourage teams to inspect and adapt. So, get the MVP version out, and then see how it performs. Ask the customer, how is this feature performing. There's no point in spending 2 or 3 months building a feature that the customer doesn't want. So yeah, very much inspect and adapt, but also having one eye on that North Star architecture of where you want to get to. And it's obviously a sliding scale as well. Just because you want to get something out quite quickly and iterate on that, it doesn't mean that you don't think about authentication or authorization or the DR capabilities, because again, that is something that I see quite a lot, where teams just want to get something out quite quickly and iterate on it without thinking of the security aspects. And so I think there's a line in there somewhere that I think teams have to find themselves.
This leads me to the topic which in this period of time in 2023 is not possible to not touch, right? We all know this case of Amazon Prime and their proof that serverless is dead and microservices are dead and cloud is dead at all, right? So we need to go back to the, I don't know, stones and paper. So what happened there is exactly what we talked about, right? This adaptation. Invest in kind of MVP which becomes like a live product, right? But with the scale, they realize that it doesn't work properly, so they just did the change. They adapt. They inspected the current state. They knew where the problem is, and they act properly on it, right? So it's not something like bad architecture on the beginning. It's not something like, yeah, serverless is dead, right? Because this is one service only and kind of supportive service for the main functionality of the Prime, right? What can be your answer from the exactly enterprise perspective, right? Where we implement the serverless approach and then we come back. It's bad saying, but we move forward back to to monolith, right? Is this something bad?
I don't think it is. I think there was obviously a lot of noise about this in the industry, but if you write your code in the right way, which I presume the team did, I don't think reading the articles that it said specifically that they had, onion architectures or hexagonal architectures. But I think the piece in the article I seen was we could reuse most of the code that we already had to then move to containers. So you could probably imply that that there was that level of clean code in there, which you would expect with Amazon anyway, I guess. But yeah, I think everything around you changes. I think change is the only one thing that's constant, and that's in your industry. It's with your customers. It's your business is going to change. So again, I think that's the key thing for me at that kind of enterprise level is just building things in the right way to allow for evolutionary architectures. That's one of the key things I try and drive home with the teams I work with.
Yeah, and this is the principle you mentioned, right? They reuse a lot of code. And again, leads me to another argument from the camp of anti-serverless and anti-cloud people, right? This is the famous vendor lock. This case here, in my opinion, proves that yes, vendor lock may be an issue, but it is not that complex and problematic issue, in fact, right? Because yes, for the serverless in the specific vendor like AWS, Azure, doesn't matter, you need to write the function, at least the handler of the function, in the specific way. That is obvious. But this is a few lines of code, in fact. What should be our cloud native guys answer to this charge that vendor lock is bad, especially from the enterprise perspective, right? Because this is the argument which we heard more with the size of the company. And with that question, we stop this episode and we will answer this question. Oh well, Lee will answer this question in the next episode. Stay tuned.
Thank you for listening to this episode of DevOps in Agile Way podcast with your host, Pawel Meets Lee. Subscribe, comment, and do not forget to check our next episodes. Stay tuned. Stay safe. Stay curious.